Right, let's rock and roll. I think I'm going to have to do this one again. I've already done this and I think I deleted the video. So, let's have a nosy. In the second stage of the manufacture of sulfuric acid, sulfur dioxide with oxygen, reacts with oxygen, the equation for the equilibrium, and here we go. I actually looked at that question, I thought, as soon as you see it in Unit 2, you think Le Chatelier. You can tell it's Le Chatelier 90% of the time on a Unit 2 paper because it's equilibrium. Let's get the pen up. Okay. State and explain the effect of an increase in temp. Okay, so we need to look at this. Delta H. Increase in temp. This is an exothermic reaction. It's giving off heat. If you think about it, if you suddenly heated it up, and as Le Chatelier said, and basically his idea was the system wants to stay in its state. If you heat it up, it wants to cool down. If you cool it down, it wants to heat up. So we're heating it up. So it wants to cool down. So our yield is going to decrease. And here's the reason why. Our yield is going to decrease because as it heats up, this is an exothermic reaction. If it's an exothermic reaction and you heat it up, the equilibrium will be shifted to the left, shifted to the left. So equilibrium is shifted to the left. This is so that the system absorbs heat, or you can turn around and say it cools down. Either of those two terms is fine, it's just the way you want to think about the ideas of what Le Chatelier said. Okay, now that's 2 marks. 1/3 the fact they're going to decrease, 3 marks. Once it decreases, the other to say that the equilibrium shifted to the left, so it absorbs heat and it cools down. Okay, let's have a look. In the extraction of iron, carbon monoxide reacts with iron 3 oxide. This is question 3. Alright, first mistake is to write this. This is not iron 3 oxide. This is iron 2. Right? And what we should actually have is Fe2O3. Now, if you didn't know that, look back at part question 3a. It tells you. This is write an equation for this reaction. So it's reacting with, and again it tells you in the question, carbon monoxide. The question is, what do we form? It actually tells you that as well. The extraction of iron. So we will be making Fe. Alright. We're making Fe, and what we will be producing is, well, we've got to lose this. We've got to lose this oxygen here, and it will form. And it will bond with the carbon monoxide to form carbon dioxide. And now we need to balance it. Oh, 2 ions. And what I'm going to do is I'm going to change to blue. I've got 2 ions here, 2 iron ions. So I must have 2 atoms here. And now comes the tricky stuff. Let's do it. Let's write down how many oxygens we've got. We've got 2 oxygens, and I like oxygens because I've got 1 carbon on either side, so I can't really balance that because they're already balanced. I've got 2 oxygens on this side, and I've got 4 oxygens on this side. So what I could do is I could double everything. I could double my carbon dioxide to give me 4 oxygens. All right, let's go ahead and do that. Let's do a thinking thing. So what I'm going to do is I'm just going to sort of shift the green to a little bit lighter. I'm going to put 2 CO2s. The thing is, if I put 2 CO2s here, yes, I've now got, let's switch back to blue, 4 oxygen atoms. I hope I was saying 4 oxygen atoms before over here. I've got 4 oxygen atoms over here. I've got 4 oxygen atoms over here. But you see now I've got 2 carbon atoms over here. Over there. That's driving me insane. So I must have 2 carbon atoms here. Oh, so now we're going mental. So if we look at this now, if we've got 2 carbon atoms here, we've got 3, 5 oxygens on this side, and we can only go up in even numbers here. So we've got 4. Oh, we can't do this. So what are we going to do? Alright, what we can do and the way to balance this is to think that I can go up in, and I'm going to switch back to blue, 1 oxygen steps over here, so I go up to 3 carbon dioxides here, so that'll give me 6, so it's carbon monoxide, 6, it's trial and error. Okay, the role of carbon monoxide. Well, the way to work out the role of carbon monoxide is to look at what happens to iron. We use 6 oxygen atoms on this side. It's a little bit tricky, but I've tried to do it in a way that doesn't require mathematical skill, not to look for multiples, but basically it's trial and error. Okay, the role of carbon monoxide. Well, the way to work out the role of carbon monoxide is to look at what happens to iron. We start off with iron at Fe3+. It goes off Fe2, Fe with no charge. So it must have gained 3 electrons. If it's gained from oil rig, we know that if something gains electrons, it is reduced. So the iron 3 is being reduced. Carbon monoxide is a reducing agent. Because it causes reduction. Okie dokie. Next. There we go.